Hello again. We're carrying on with our series of tutorial videos on the use of qtVlm for basic chart plotting. And in this example, we'll do a basic vector solution for finding the course made good when we're sailing in a given current. This would be the same operation you would do, same vector solution you would do for finding true apparent wind from true wind and so forth. And you'll see that in a moment. And we're going to be doing one of the exercises out of the workbook, this one here, which gives several exercises to plot with. I'll work out this one directly and then just show these other two, which I have plotted already. Now for this, I have a chart showing here, but we actually don't need a chart. We could shut the chart off, completely, like that. Or let's see, can I shut all the charts off? Yeah, I guess like that. So there's just a plain blank waterway, and that works fine. We're just doing a vector solution. Now, when you're actually doing this underway, there's no need to shut off your chart unless it's confusing. But okay, so we're going to do this when I'm heading 350 at a speed of 7.5. And I'm in a current that's 1.8 towards 260. Now, generally, we don't know the current that precisely at any time, but it's good to have. We always have an estimate of the current wherever we are. We have an estimate of some kind, and this is a way that you would figure your estimate then of what your course and speed made good would be. Okay, so let's start. This is a path. We solve these vectors with a pathway. So we create a pathway. I'll call this one, it doesn't matter. I'll just call this 9-11D, say. Okay, and then from the first mark, and then I append the POIs. And so again, we rough it out first. You would do a vector problem like this, or even laying out any application. You lay it out. You just rough it out first and then fine tune it. So we'll start out somewhere here, and we're heading 350. Oh, it's magnetic. That's like some over here somewhere. And then that's the 1 hour drive in the boat. And then the water during that time is moving 1.8 at 260 plus 20, somewhere up like this. Now again, well, it's not that far, obviously. Something like that. And then, again, it doesn't matter if you're doing magnetic or true in your thinking about the plotting, as long as you're consistent. And then whatever you get, if we have magnetic heading, then we're going to get magnetic course made good. Or if we did true, we would get true, and so forth. And so once we're here, then we just connect back to here. Like that, and then escape. So basically what it is we go in 1 hour from here to here. The current goes in 1 hour from here to here. So that's effectively the same as us going from here to here over the fixed Earth. And now what we do is fix these to be the right values. And so we want 350. Let's see, where's 350? I'm going to come from the smaller one, and I want that to be, what, 7.5? Okay, there's 7.4. 7.5 is here, and I want that at 350. That's 48, 49. That's about 350, and that is 7.5. Okay, does that agree? There I'm reading what? 7.5, 350. Okay, close enough. And then this is now the current, which is 1.8. And we can zoom, you can always zoom in. 1.8 in direction 260. 260. Okay, there's about 260 right there. And 1.8, there's 1.8 at about 260. Okay, that's close enough. What's that read? 1. oh no, I read the wrong one. This one here, 1.8 at 260. Okay, so there's our true vector. I mean, we went this way. We went in 1 hour. We sailed 7.5 miles this direction. The current moved in that same hour. The whole current in this whole area moved that way, 1.8 miles in direction 260. So that means our direction, our course made good is this one. Our speed made good is this length in an hour. Now we can measure that directly. What do we get here? 7.7. 7.7. And, okay, 7.7. And then, but the direction's wrong. You see, we went here, here, and here. But the current, we have to reverse this direction to get our net direction we actually made good. So we just go here, edit, and reverse this. Okay, and then we can read it, and then I'm getting 336.7. Well, okay, so here then is the answers over here. You see 336.7, they got 337 and 7.7, so that's the same. And so there are here then, there's just two others. Now once you have this vector drawn here, then you can just say, you can just change the vector. Like now I've got that many miles there, and I've got my current over here, and this is my speed made good and course made good. And here then are the other two examples that are in that exercise that are shown here. And so here goes, this is heading out at, oh no, where is this one? This is the first one. Oh, 200. Okay, so here is 200 at 6 knots, and then you have a current of 2 knots at 150. Here's the 2 knots at 150. And so then here is the speed. The speed is 7.4, but then I have to edit and reverse the direction. Edit, reverse, reverse. And then I can get the course made good is 188. And then that's it. That's the answers in the book here, 188 and 7.4. Okay, so I'll stop there. Those are the whole series of these you can practice. You draw that 3-legged closed route, and that's your vector that you use to solve these current problems.